So question 14 is a tricky one. It is worth all of 9 marks. So it does mean that we're going to be having to do quite a bit of work for this question. Now, it does ask us here at the start to calculate the area of the shaded sector. Now we know that the area of a sector, so I'm just going to write that at the start on the top of our page, is our angle in the middle, so this angle that we want to find out here, over 360 degrees, because we're looking at what fraction of the circle that we want, times by the area of a circle, which is pi r squared. So we could guess that we do need to find out that angle in order to give us our answer. Now the next thing I'd look at is what information do I have? Well, from the left hand side here, just outside the circle, I've got an angle with two sides either side of it. So I've got two sides and an included angle. Now that should tell me that I'm going to use my cos rule, my cosine rule. And we should remember that our cosine rule is a squared equals b squared plus c squared minus 2bc cos of capital A. Now, if we're going to use that, that means that we can work out this edge by here from P to Q. And if we've got that, knowing that that 8 centimeters is the radius of the circle, means that we know that other side is 8 centimeters. And then we would have three sides of that triangle, which means we could use the cosine rule for a second time to work out that missing angle, which is the all-important part of this question. So that is our strategy, and that's all come from us knowing that to find the area of our shaded sector, we needed to find out that angle. Okay, so just to recap, we needed to find that angle. Well, how could we do that? Well, we looked at the information we had. The information led us only to one conclusion: we'd have to use the cosine rule. That meant using that we knew that we could find that length PQ, and then we knew that if we've got that length PQ, we've got three sides, and we can work out that missing angle in the middle of our circle. So let's get to work. So the first part, we're going to use that cosine rule to work out that missing length. So our a squared is going to be our b squared plus c squared, so it doesn't matter which we choose for b and c, so let's call it 4 squared plus 6 squared minus 2 lots of 4 times 6 times cos of that angle that we've got, which is 82 degrees. Now that gives us that a squared is 45.319, etc. I'm going to keep that whole number because when we square root that number, so in your calculator just write square root of answer, that gives us 6.7319. Now again, I'm not going to round that answer yet. I'm only going to round it my final answer to keep and retain my accuracy, but I am going to put that 6.7 onto my diagram just so that I know what I'm going to use in order to work out my final part of my answer. So for the final part of my answer, I've got my three lengths which I know, and I'm just after that angle theta. So I'm going to write it in the same way. So I'm going to write a squared equals my b squared plus c squared minus my 2bc cos of A. So I want to find out what my angle is. So I'm going to find out my angle, and the letter that needs to be opposite that is my A. So I've got my capital A and my little a. So in my diagram, the number that is opposite my angle is 6.7, so that needs to stay as the number that is becoming squared. My b squared and c squared, well, I know that they're both going to be 8 squared, and I know that B and C again are both 8 in this final part, cos of A, which is what I want to find. So just scrolling down, so what I'm going to do now is just keep that left hand side the same, my 6.7 etc. squared. 8 squared is 64 and 8 squared is 64, so 64 and 64 is 128. 8 times 8 is 64 times 2 again is 128 cos of A. Now I want to find out what that cos of A is, but at the moment we can see here that we've got a negative sign. So we're just going to rearrange to make that positive. So we're going to add that 128 cos A to both sides, and we're going to take away that 6.7 squared from both sides, and that means that we've then got our cos of A. So to get rid of that 128, we're going to divide by 128, and so all that is left to do is to work out the inverse cos of that. But before that, I'm just going to work out what the value of that is on my right hand side. Now it's worth retaining the accuracy in your answer, so when you're typing this into your calculator you should just be able to type 128 minus your answer squared divided by the 128, and that gives you a value of 0.645 etc. And so to work out A, so to get rid of the cos, we do the inverse of cos of that number that we've come up with, and that will give us our angle. So the inverse cos of that answer gives us an angle of 49.76 etc. And again, I keep that and I don't round it because I'm still not yet at my final answer. So to finish, I just need to put that angle into my formula for my area of a sector. So just in the space that I've got here, so we're going to use this formula for the area of our sector. So we know that our angle was 49.7 etc. over 360 times pi, and we know that our radius is our 8 centimeters, so pi times 8 squared. So on your calculators you should be able to type again just your answer button divided by 360 times your pi times that radius squared, so that 8 squared. And so that gives us an area of 27.79 etc. And because we've kept that accuracy, we know that's perfectly correct up to our number of decimal places we want to round it to. So we're going to round it to, let's say, 2 decimal places, and so that will give us 27.79 centimeters squared. So quite a lot of work using our cosine rule twice, but all stemming from the fact that we recognised to calculate the area of our sector we needed to work out that angle in the middle.